Alright guys, so hopefully you had a good weekend and you got 1.3 Hawks done. We're going to do polynomials, the complex number system, so we're still in Unit 2, um, but now we're going to talk about imaginary numbers, aka the complex number system. So we're just going to perform operations with complex numbers, but before we do that, let's talk about just simplifying square roots like we used to. So if it's a square root, remember I want to make pairs, so this one splits into a pair of 9s. If I have 5 y's, I can make 2 pairs. So on the outside, I would have 9y squared, and then on the inside, I would have the square root of y, and that would be my answer, right? Same way over here, in order to add them, they have to be the same. So if I could do 2 and 4, and then 2 and 2, make a pair of 2's, this one ends up being 2 and 25, 5 and 5. So I'm going to rewrite it. It's going to be 6x times 2, square root of 2, plus 5 times x square root of 2. When you do this, you get 12x square root of 2 plus 5x square root of 2, which ends up being 17x square root of 2. Alright, so that's just a review over simplifying square roots. Now we're going to do the same thing, but we're applying it to imaginary numbers. So if you have a square root and it's got a negative number on the inside, alright, we're going to talk about I. So we're pulling out the imaginary unit. So I squared is equal to -1. We'll talk about that a little bit more in depth too. This means we can take the square root of negative numbers now. So for example, before we used to do this was no answer, but now it's going to be 2i because we have the imaginary number system now. So simplify the following expressions. Again, you're looking for pairs, so if we break it down, 3 and 9, 3 and 3. All right, that -1, okay, is going to be I. So another way to write all this is we can split it into a pair of 3's makes a square root of 9, so this becomes 3i square root of 3. So again, that negative is equal to I, so that's why I have 3i square root of 3. Same way here, if we break it down, 5 and 25, that becomes 5 and 5, so I make a pair of 5's. The negative is going to be an I. There's already a negative on the outside, so you just write -5i, and whatever I have left over still stays inside that square root. Last one, negative is an I. Okay, I can make a pair of 2's out of that 4. I can make one pair of x's, and I have one x left over. So I'm going to take 3y times 2xi square root of x. So this becomes 6xyi squared of x. Again, the big difference here was nothing new. The only thing is now we can do the negative on the inside. So let's talk about like I to the first, and then we'll elaborate a little bit on this because it'll help you with some of the Hawks questions. So I to the first is equal to I, which is the square root of -1. I squared is the square root of -1 squared, which is -1. I cubed, if you break it down, is I squared times I, which is equal to -1 times I, which is equal to -I. And lastly, I to the fourth is I squared times I squared, which is -1 times -1, which is equal to a +1. So we're going to use this to help us simplify. So this one I'm multiplying. So 3 times 4 would give me 12. I times I would give me I squared. Well, we know that I squared is -1. So this becomes 12 times -1, which is equal to -12. If I have I to the 187, the easiest way to simplify these is you take 187 and you divide it by 4. So when you do that, 187 divided by 4, you get 46.75, aka you have 46 remainder 3. So one way to think about this is I can rewrite this as I to the fourth, because I divided by 4, to the 46th power, because that's how many times I went into it evenly. Now what I have left is 3 of them, so I'm going to multiply by I cubed. So let's just sub in what we know. I to the fourth is 1 to the 46th power, and I cubed is -I. So lastly, 1 to the 46 is going to be 1. 1 times negative I is just negative I. So that's how you break down something that they give you a really big exponent. You divide it by 4, and then you figure out what your remainder is, and you go from there. Next one, what I would do is I would simplify your square root first before I multiplied. Right, so the negative is going to be an I. That's 2 and 6, 2 and 3, so that's a pair of 2's. So I have 2I times 3 times 2I square root of 3. When you do this, I multiply 2I times 3 would give me 6I. 6I times 2I would give me 12I squared, square root of 3. We know that I squared is equal to negative 1, so this becomes negative 12 square root of 3. Next one, I to the 11th times 12 over 2I to the 8th. So the first thing I would do would be to multiply I to the 11th to 12. So I'm going to do that one out here. You're going to get 12I to the 11th over 2I to the 8th. Now, properties of exponents, we can simplify this. So 12 divided by 2 would be 6. If it's division, I subtract the exponent, so 11 minus 8 would give me I to the third. Remember, we know what I to the third is. It's negative I. So my answer is negative 6I. Again, same thing, if they give you a really big exponent, I would divide it by 4 first. So 115 divided by 4 is going to give you 28.75. So I have remainder 3 again. So I would do 3 times I to the 4th. It's 28 times I cubed. So this is 3 times 1 to the 28th times negative I. Just simplified everything I knew. And it becomes negative 3I whenever you multiply everything. Last one, square roots. Again, what I would do is I would simplify the square roots first. So if you break this down, you can do 49 and 2, which would be 7 and 7. Don't forget the I is a negative, so that becomes 7I squared to 2. This one, all I can do is the I, so I'm multiplying by I squared to 2. When you do that, you get 7I squared square root of 4, because I can multiply what's inside the square roots, which becomes 7 times negative 1 times 2, which is just negative 14. Okay? So that's just some basic operations with the imaginary number. If you have any questions, let me know on that part. I know that's kind of the harder part. The next part, operations, so we can still add and subtract with imaginary numbers. So simplify each of the expressions. The first thing I would do here is I would distribute. So you get negative 2 plus 5I plus 2 minus 14I. Now I can just combine. The only thing you can combine is the real numbers, and the imaginary numbers are their own unit that I combine. So when you do this, negative 2 plus 2 is 0. 5I minus 14I is negative 9I. So that's your answer. So adding and subtracting is pretty easy because all you can do is combine the real numbers and the imaginary numbers. So this one I'm going to rewrite because this negative goes to both of those, so it turns into plus 1 minus 2I. And again, all I can combine is the real numbers, so that becomes 5. And the imaginary numbers, so that becomes plus 4I. All right, so adding and subtracting is pretty easy. When you multiply, same thing, you're just going to FOIL like we had before. However, you have to be careful on some things. So if I FOIL, I end up getting 6 minus 12I plus 10I minus 20I squared, right? Because the last one, you're going to get I times I. Now don't forget, we know what I squared is. It's negative 1. So I'm going to combine these two to get 6 minus 2I. And then I'm going to take this negative 20 times a negative 1. So that turns into plus 20. So this becomes 26 minus 2I. whenever you FOIL. I challenge you to pause the video and try B. Same thing, distribute. When you do this, all I can do is combine those. So that becomes 46i. Remember, this is negative 42 times a negative 1, so that turns into plus 42. So I have plus 30 because I would take 42 minus 12 to get that 30. Remember, if it's squared, we know how to write this. 5 plus 2i, and then we just do what we've been doing. We would still FOIL. So when you FOIL, you get 25 plus 10i plus 10i plus 4i squared. Remember, this is times a negative 1. So it becomes 25 minus 4, which is 21, plus 20i. Last one's just adding again, threw in another one. They do try to trick you because they didn't simplify it. I squared is negative 1, so this becomes a negative 8 minus 8i plus 2 plus 6i. And then I would combine like terms. So negative 6 minus 2i. All right, last one's the hardest one. So if you have an imaginary number on the bottom that's not what you want, so you have to rationalize the denominator. The easiest way to do this, or the only way to do it, is you take what you have on the bottom and you change the sign in the middle. And I multiply the top and the bottom by 4 minus 3i. So on top, I'm going to distribute 25 times 4 to get 100 minus 75i. On bottom, you have to FOIL. So I get 16 minus 12i plus 12i minus 9i squared. And the reason why we do this is because I squared is going to become negative 1. So this becomes plus 9. And your negative 12i and your positive 12i are going to cancel. So now I have no imaginary numbers on bottom, which is what my goal is. So you get over 25, and then you just simplify the fraction. 100 divided by 25 is 4. 75 divided by 25 is 3. Again, you can't have imaginary numbers at the bottom, so you multiply by what's on the bottom, but you change the sign in the middle. So it was a plus, so now I'm going to use a minus. Now this one you have to FOIL on top and bottom. So I FOIL on top. It's okay, they don't cancel on top. Your i's, you can have i's on top, just not on bottom of a fraction. But whenever you FOIL, you end up getting this on top and bottom. So then I would simplify. Do not forget I squared is negative 1. So this becomes 6 plus 16 on top, which would be 22, plus 20i, because I would add these two. On bottom, your i's are going to cancel, so then I have 36 plus 16, which should be 52. And you just simplify. I can divide them all by 2, so I get 11 plus 20i over 26. And that's the whole lesson. So imaginary numbers are kind of difficult. I know this is a tough lesson. Your homework is going to be certify, I believe, let me look it up real quick. It'll be 1.4. If you have any questions over it, please let me know. Otherwise, have a good day, guys.